Hi everyone, in this video we're going to go through 3F using transformations to sketch graphs. So there's quite a few here to do, so I would strongly encourage you to watch a few until you've got the hang of it and then attempt some on your own and then check how you went. So, you know, at any time you can obviously fast forward this video. Yeah, so let's get started because it's going to be a long video and I'll try to be as interesting as I can, but it is very repetitive. And as I said, as soon as you get the skills or you think, oh yeah, I got that, then maybe have a go at doing it on your own. Okay, so the first function we have a hyperbola. So in this spot, in this spot here, we're just going to draw the basic hyperbola. And that's not it. I was about to draw a truncus. Silly Billy. All right. There's our hyperbola. So what I might do is also show you on Desmos the graph. So let's just get, I'm going to cancel that. Desmos. Okay, so our basic hyperbola is 1 over x. All right, there it is. Now, the function we're doing is 3 over x minus 1. So what is happening here is we've been dilated and it's been translated. Actually, I probably should have done the original graph. I wonder if it's going to do, oh, sorry, minus x. Okay, so you can see the blue graph, our basic hyperbola, has been transformed to the red graph. Now, when you're sketching, so we're focusing on sketching in this video, it's always important to choose a point. So on our basic graph, the blue one, this point here is 1, 1. Now you could choose any point on this curve, or you might be given a point, and you need to know how to transform that. Now, the reason I've chosen 1, 1, well, what I did choose was x equals 1, but the corresponding y value is also 1 for this graph. And because I chose x equals 1, I'm going to do x equals -1. Oh, I didn't quite get it on the corner of the grid line. Let's see how I go this time. Oh, all right, there we go. So -1, -1. All right, so we're choosing those 2 points to actually map our, to do some mapping, to draw our red graph. Because just remember, you're not always going to have your calculator, so you need to be able to sketch. Okay, so in the previous section in 3E, we actually looked at the transformations, what the transformations were. So we're effectively doing the same thing, but instead of talking about the transformations, we're graphing. Okay, so we're going from y equals 1 over x, your basic hyperbola, to y dash equals 3 over x dash minus 1. So that's the image, all right, after our transformation. Now, just rearranging the image, so that 3 I'm going to bring over by dividing by 3, and then I've got 1 over x dash minus 1. Now, the reason I'm doing that is it's easier to see the transformations if you've got your right-hand side in a similar way to your basic graph. So we've got 1 over x here, so basically in our the image function, we want it to be 1 over something, and then it's just easier to see what your transformations are. And I'm going to run out of room here, but anyway, so your x has become x dash minus 1, so x dash is equal to x plus 1. So we're basically, when we're looking at what the transformations are, we want x dash. So this means the graph has been shifted to the right by 1. And let's do the same with the y. So we've got y dash is equal to 3y. So that means we've had a dilation factor 3 from the x-axis. All right, so it's been pulled away from the x-axis. All right, so remember before I was talking about mapping the points? So I'm going to take just your generic xy point, and what is happening to our x? We're adding 1, And what is happening to our y? We're multiplying it by 3. And I'm sorry, it might be a little bit hard to see. Let's just make it a bit bigger. There we go. All right, so remember before I said, okay, the 0.11 is on this graph. So there it is, 1, 1. And this point over here was -1, -1. And we also have two asymptotes. So the asymptotes for your basic hyperbola are the axes. So just make sure you don't forget your, can't talk properly today, your asymptote. So that line is y equals 0. And then our vertical line is x equals 0. All right, so there are asymptotes for your basic hyperbola. So let's see how things have shifted. So we did have the 0.11 on our original graph. So now it becomes 1 plus 1, which is 2. So remember, I'm just looking at the mapping here. So 1 plus 1 is 2, and then 3 times 1 is 3. Okay, so this point here has been transformed to 2, 3, or shifted to 2, 3. And then our point -1, -1. So -1 plus 1 is 0, and 3 times -1 is -3. Now the good thing about this point is it's also our y-intercept, okay, because x equals 0, which is great when we're graphing, because if I, oh gosh, I can't draw a straight line. So if I didn't know, actually I think I can use a tool to draw a straight line, but I really should, because you know it's always entertaining watching me struggle to draw graphs. Oops, I think let's see what happens now if I do that. Are you going to go straight for me? No. It does it if I draw a symbol. Oh, that went straighter. So if I draw a love heart, I think that's going to, no. Did it the other day with the circle. There we go. Anyway, we don't need a circle, so we'll just get rid of that. Sorry. Excuse me, I rubbed you out. There we go. All right, sorry about that, got a bit distracted. Okay, so let's get back to our transformation. So our asymptote, so let's think about how our asymptotes have changed. So when you're sketching a graph, always start with your asymptotes and be confident with them, all right? Because with asymptotes, it's a good idea to put them down in pen. So our graph has been shifted to the right one. So our vertical asymptote has gone from x equals 0 to x equals 1. So I would go ahead and draw that in pen. My horizontal asymptote remains the same because the graph hasn't shifted up or down. So it stays as y equals 0. All right, now asymptotes in pen with your, see how we go with this pencil. When you're sketching a graph, it's a good idea to do it in pencil, especially on your exam. And you need to have smooth lines. Okay, so what I mean by that, and it's very rare to see this, but I'd hate for you to do it like, here's your pencil, and you're kind of doing something like that. All right, it needs to kind of be one smooth line. I don't really like that pencil. Let's see if I can get it a bit darker. See what I've got going on here. See how that goes. Okay, so we want to plot the 2 points. So the first one is 2, 3. So I'm going to put that up there. It's not the best pencil, is it? And then our other point has gone to 0, -3. If I can get that a little bit sharper, darker. I don't think that's going to make any difference. Okay, so just make sure your hyperbola is going through those points. Oh, I like this one better. That's good. Can't draw though. Doesn't help with my drawing, but just makes it look a bit. Yeah, that curve's better than the other curve. Let's make sure I've labelled it correctly. Okay, so we've got our hyperbola. Now, on an exam or on a SAC, you'll be given, usually you'll be given a scale. I don't want to guarantee it. But if you're not given a scale, just put one in. All right, so I didn't put one in for this one, but because it would be here forever. But just make sure if you're doing any sketching, you really need to be accurate. All right, you just can't go like I've done on the screen. All right, now my drawing's not the best because it's very hard to draw on the computer, but in person, hopefully you would be a lot better. All right, so this question does ask us to state the domain, the range, the asymptotes, the axes, intercepts, and that's it for each function. So I'm going to do that over here. So first of all, we need the domain, we need the range, we need the asymptotes, and we need the y-intercept, and we'll do the x-intercept as well. All right, so your domain, what can your x values be? So basically they can be any real value excluding that asymptote. So that asymptote is going through 1, so any real values except for 1. Now your range is any real value except for 0 because it's got an asymptote at y equals 0. So your hyperbola goes very, very, very close to your asymptotes, but they never cross. So now we've got our asymptotes. We've got one at x equals 1 and one at y equals 0. And then your y-intercept we did before was 0, -3. Now make sure when you're doing coordinates you use curved brackets. All right, always. Because if you use square brackets, you're going to get it wrong. All right, and then there's no x-intercept, so none. All right, so always use curved brackets for coordinates. When you're doing your domain and range, remember they can be either square or curved, depending on whether the value is included or not. So when I talk about, actually we'll do it with the next one. Not enough space to do it there. All right, moving on to, what do we got? H of x equals 3 over x minus 2 squared. So we're going from a truncus this time. Oh God, sorry. Why that happens sometimes. Okay, try again. You gonna work this time? Thank you. Oh. I think it was because I had my hand on the tablet. So precious. There we go. All right, so your basic truncus shape looks like that. All right, so let's do it on Desmos, and I really encourage you to draw, get rid of that for now. All right, so there's your truncus. So what I was saying is use Desmos to graph. Okay, I know you can use your calculator, but Desmos is so much more user-friendly and just getting used to quickly looking at the transformations. Obviously, you need to be able to do it on your calculator as well, but just while we're learning this, go on to Desmos and do it. All right, now what do we got? 3 over x minus 2 squared. All right, so let's do the other graph. Power of 2 and change that to 2. All right, so there you can see our transformed graph. It's been shifted to the right 2, and it's also been dilated by a factor of 3 from the y-axis, from the x-axis. Now, some of you will pick that up straight away, and you don't need to do your mapping, right? And that's fine. Nothing wrong with that. Okay. In fact, I would do that. I wouldn't always do mapping, but you really need to practice your mapping, all right? Because you're not always going to get easy functions. All right, so we're going from y equals 1 over x minus, oops, not just x squared. All right, that's our basic truncus, and we're going to y dash equals 3 over x dash minus 2 squared. All right, I'm just going to bring that 3 over, so divide both sides by 3. All right, so your x, and I'm kind of just using up a bit of space here, your x has become x dash minus 2. Notice how I've got it in a bracket. Oh, well, it was in a bracket in the question. Just thinking. All right, well, maybe we'll come across an example later. Oh, I didn't have to put that in brackets there though. Sorry. Okay, so your image has become x plus 2. And then for your y, it's from y dash on 3. So y dash is 3y. So your point xy, or your coordinate, sorry, xy become x plus 2. And then dilation 3y. 3y. Okay, so 2 points on your truncus. So now let's do it without pointing on the graph. Let's let x equal 1. When you substitute in x equal 1 into your basic truncus, so we're doing this one first, the y equals 1 over x. Letting x equal 1, we're going to get 1 again. So there's the point 1, 1. It's not always going to be the case. All right, just a heads up. And then what do we have? Negative 1. So when x equals negative 1, y equals 1. Oops, got to put the squared on there. So we've got negative 1, 1. So we're going to use those 2 points to map. All right, so we've got 1, 1. And that's going to become 1 plus 2 is 3. And then 3 times 1 is 3. And our other point, negative 1, 1, becomes negative 1 plus 2 is 1, and then 1 times 3 is 3. All right, our asymptotes for this graph, we've got not y equals 0, x equals 0. And here we've got y equals 0. All right, so our graph is shifted to the right too. So that vertical asymptote, oh no, I did it around the wrong way. I had it correct the first time. Sorry, my bad. Yeah, silly Billy. Okay, y, x. That vertical asymptote has shifted to the right too. If you ever think I've made a mistake, girls, often I will realize it soon. So just keep watching. I have faith that it'll take me a while, but I'll get there and see the mistake. All right, so 1, 1 has become 3, 3. So I'm going to put that on here. It's a point 3, 3. And then we've got 1, 3. All right, so our truncus is coming up like so. Oh, gosh, I wasn't even paying attention. Let's try again because it should go through that point. Or was it really paying attention? There we go. And through this one. All right, kind of looks like a monster. Anyway, getting distracted. All right, so there's our h of x. Okay, so let's label our domain, range, asymptotes, x-intercept, y-intercept. Okay, so your domain with a truncus, it's any real value excluding that vertical asymptote, so excluding 2. Oh god, a bit sloppy, sorry. Your range, now for a truncus, for your basic truncus, you've got a horizontal asymptote at y equals 0. Now, because we didn't shift up or down, and we also didn't have a reflection, that asymptote stays at y equals 0. So your range is any positive real value. Now, when we write r positive, that doesn't include 0, so it's all good to do that. Or you can write it as 0 to infinity. Now, 0 has a curved bracket because it's not included. Okay, so just remember that. All right, we've got an asymptote at x equals 2 and y equals 0. There is no x-intercept. Now for your y-intercept, unfortunately, neither point came out as a y-intercept, but all we need to do is let x equal 0. So we've got h of 0 equals 3 over 0 minus 2 squared, which is 3 over 4. So this point here And because I've drawn such an accurate graph, you can see it goes through y equals 3 over 4. All right, moving along. Now we've got a square root graph. All right, so let's go back to our Desmos. Get rid of you for now. Now, if you're doing it on a square root graph or square root at all on Desmos, it's just square root, or you can use, there's a little calculator down here that you can use. I don't think you can see on my screen. So there's your square root graph. It does include 0, 0, because the square root of 0 is 0. You can take the square root of 0. So when I'm sketching that, all right, there is the point 0, 0, and it's going up like so. Now, if you're picking another point on that graph, think of your perfect squares. So 4 is a perfect square, so that goes through 4, 2, because the square root of 4 is 2. The next perfect square would be 9. So there we go. It's at, should be 9, 3. Come on, where are you? There we go. Or you could also do 1, 1. Where's 1, 1? There. Not quite there. There we go. All right, so you want, when you're dealing with square root graphs, try to think, well, under that square root sign, you need a perfect square. So at the moment, it's just x. So I can say, well, if I let x equal 1, x equal 4, x equal 9, I'm going to be able to put points on my graph. So, oh, sorry about that. So let's just plot a few. So I'll call that 1, 1, and we'll do 4, 2. So not the most accurate scale, but it'll do 4, 2. Okay. And oh, we got 0, 0 as well. Let's put that in. Oh, I have a feeling that my computer is going to glitch. All right, so our basic square root graph is y equals the square root of x, and that's transformed to y dash equals negative square root of x dash minus 3. All right, so I'm just going to transform my image by, translate the equation of my image by multiplying both sides by a negative. So basically I'm bringing that negative sign over. All right. You can't put that negative sign into the square root. All right, so just be aware of that. We're going to take it over to the other side. So there is a reflection. So we've got a reflection, oh gosh, in the y-axis. Didn't say that with much confidence, did I? That's why mapping is important. I can always tell once I've done my mapping. I think it's in the x-axis. Yeah, in the x-axis. All right, so our x has become x dash minus 3. So x dash is equal to x plus 3. So we shifted to the right by 3. And then our y has become, let's make room for my negative sign, negative y. So y dash is equal to negative y. So our coordinates x, y have become x plus 3 and negative y. So we've shifted to the right 3 and we've had a reflection in the x-axis. Now, if you're, like I was before, was I reflecting in the y or the x? That's why having these points does help. So 0.00, excuse me, get back on there, becomes 0 plus 3, which is 3, and negative 1 times 0 is just 0. And so that's shifted, as you think, as you would expect, it's shifted along the x-axis by 3. And then our other point, 1, 1. So that becomes 1 plus 3 is 4, and 1 times negative 1 is negative 1. And then another point is 4, 2. So 4 plus 3 is 7, and then negative 2. Now, if this keeps glitching, I'm going to have to, oh, you know what? I haven't been drawing my graphs in pencil. I went to all that effort to choose a pencil. Sketch it in pencil. All right, so we've got 0, 3. So there it is, 0. We'll label it later. 1, 1. Oh, sorry, 1, 1 has become 4, negative 1. Yeah, it's glitching on me. And then we've got 7, negative 2. So it's probably going to be more out here. All right, so my graph, which I would draw in pencil, but it's glitching on me. All right, so it goes like that. So you can see it's shifted to the right 3, and then it's been reflected in the x-axis. So this point here is 3, 0. And this point is 4, negative 1. And this point here is 7, negative 2. And obviously it would keep going. It wouldn't stop at that point. When you do sketch your graphs, do make sure you go over, oh, excuse me. No wonder it wasn't working. I had it on ink to shape. That's so weird. How do I even get rid of you? Let's see. Sorry, girls. All right. Gotta write the word domain and it draws a arrow for me. All right, so the domain, the range. We've got asymptotes. X-intercept and y-intercept. All right, so our domain, what values can x take on? Now, this endpoint is included, so we use a square bracket. All right, so we're starting at 3 and we're going to infinity. All right, so your graph does keep going. Your range, this is a little bit harder. So we're actually, if you think going up the y-axis, we're actually starting at negative infinity. Now, infinity and negative infinity will always have curved brackets, and that's going all the way up to 0, and 0 is included. All right, so there's an example of using square and round brackets. So if it's included, you use square brackets, and the 0.30 is included. All right, we don't have any asymptotes. X-intercept, which was great because it was one of our points, has become 3, 0, and no y-intercept. All right, so it's a little bit harder. All right, let's keep going. All right, so we've got y, our basic graph is, oh gosh, not that one, square root graph. And it's become y dash equals negative 5 square root of x dash plus 2. Got quite a few transformations with this one. All right, so I'm going to add 2 to both sides first. And then I'm going to divide by negative 5. Okay, so what I've just done is I needed to transpose the equation to get it to look like the basic function, y equals the square root of x. All right, so your y, I'm running out, I'm not going to have much room to write this one. Your y has become y dash plus 2 over negative 5. So y dash, our transformed, is negative 5y minus 2. I might put a square bracket around that. So I just did that in 2 steps. So, in 1 step, multiplying both sides by negative 5 and then subtracting that 2. Now, just be careful with your negatives. All right, so I see how I left that negative 5 there instead of multiplying the numerator by negative. If I did that, there's nothing wrong with that because I could also take the negative out as a common factor, but I'm not going to do that. I'm just going to say there is a reflection. All right, and your x has become x dash plus 2, so x dash is x minus 2. All right, let's draw our square root graph. Remember we drew one before. Remember, you should be doing it in pencil. All right, so this is 0, 0, and we had 1, 1, and 4, 2. All right, and just bear with me. Probably shouldn't do it symmetrical like that because, you know, it might not even be on the graph, on the grid. All right, I'm just doing that so we've got a bit of space. All right, xy has now become x minus 2. All right, so we've gone to the left by 2, and our y has become negative 5y minus 2. Now, when I talk about these transformations, I just want to focus on the y transformation for now. I've got negative 5y minus 2. So remember, your order of transformations is important because if I said the translation first, so I've shifted down 2, and then I said a reflection and a dilation, you're going to get it wrong. So you say, all right, dilation, reflection, translation. So it's been reflected, or it's been dilated by a factor of 5 from the x-axis, it's been reflected in the x-axis, and we've translated down by 2. So let's just look at what's happened to our point. So I'll do that down here. So 0, 0 has become 0 minus 2, which is minus 2. And then negative 5 times 0 minus 2. So this is going to become negative 2 as well. 0.11. 1 minus 2 is negative 1. And negative 5 times 1 is negative 5. Minus 2 is negative 7. Then our other point, 4, 2. So 4 minus 2 is 2. Now I'm just making sure I haven't messed anything up here. Yeah, I think because it's been shifted down, we've had 2 translations. That's why it's confused me a little bit. So we're going to cross our axes. And negative 5 times 2 is negative 10. Minus 2 is negative 12. All right, so what I'm going to do just before I sketch it is just make sure that I've drawn it correctly. So negative 5, 2, and 2. Oops. All right, let's just sketch that. Now, that should be negative 2, negative 2, that's right. So, there we go. What was the other points we had? I don't remember. Negative 1, negative 7. So negative 1, so there, negative 7. You can see we've got an x-intercept, which we will plot. You can see it's just over 9. That's probably because we've got the square root sign. Where are we going? Back to here. And our other point, 2, negative 12. So x equals 2, and there it is there. All right, so see them all on the graph. So what has happened to this graph is it's been reflected. We've had it's been dilated by a factor of 5 from the x-axis. It's been shifted down 2, and it's been shifted to the left 2. All right, where are we? Okay, so let's plot those points. So negative 2, actually I might do the 2, negative 12, just so we don't miss it. Don't know why I put it there. So that was 2, negative 12. Negative 1, negative 7. So we're on this side now. -1, -7. And what was the other one? -2, 2. All right, so this is our endpoint, -2, -2. So we, oh gosh, it's terrible. Going down like that. That's not too bad. All right, so let's list our points. We've got domain, range, asymptotes. We've got no x-intercept, so I might put that first just to leave us with a bit of space to do our y-intercept. All right, our range. So we're starting at -2 and it includes -2 and we're going to infinity. Your range, now because we're going, all right, see how your graph is going down, but remember, you always write your lowest value first. So we're going from -infinity to -2, square brackets. No asymptotes. X-intercept, there are none. There is none. And your y-intercept. So let's let x equal 0. So what's our function? -5 square root of 0 plus 2 minus 2. So we're going to have -5 root 2 minus 2. And just leave it as an exact value. All right. We know it's got to be somewhere between -7 and -12. We know it's close to 9, but it doesn't matter. We can just say, well, I know it's, if I've graphed those other 2 points correctly, it's roughly there. So that point there is 0, -5 root 2 minus 2. All right. Hasn't glitched yet. How many more have we got? Oh, a lot. Okay, so we actually did, those two were quite difficult. All right, but they're good to do. See how the mapping really, really helps, especially with sketching. All right, because one like this, you might get confused with your dilations or your reflections. And then if you don't get the order correct, yeah, it might be a little bit, yeah, difficult to do. You can also, actually, I'm just talking aloud. You can also sketch this function. Oh, I just realized I got to move my car. All right. Oh no, it was a neighbor, but I do have to remove my car. So what I might do is end here and do a second video for the remaining ones. Okay, so if you wanted to sketch this, you could do a table of values as well. So you could say, all right, what do I get when x equals 1, 2, 3, 4, 5? The only problem is you're probably going to deal with surds, which aren't always fun. So some things it will work with, but I feel like the mapping really helps with your points, but also on an exam, often you will see they've given you the graph with points, and it's kind of expected that you use those points to draw your image. All right, so I'm going to end the video here and I'll do a second video on the remaining ones. So might be a good idea to do some graphing on your own. Remember to use Desmos. So for the next one, I can see it's going to be a bit tricky. I probably should have done this one as well. But just to help you, even if it's just to look at those points. All right, and remember, you can say, well, what's happened to the point 1, 1? And that might give you an indication if you're on the right track. All right, guys, bye-bye.